Okay, so for the arithmetic sequences, what we need to do is there's a couple of parts to figure out if a sequence is an arithmetic sequence. We have to be able to decide if it's got a common difference. In other words, is the same number being added or subtracted each time? And of course, they told us that these are arithmetic sequences. So that's kind of a moot point. But so here's what's happening. So I've got 6 to 10. It's going from 6 to 10, from 10 to 14, and 14 to 18 for the part A. So what I'm noticing that I'm adding 4 each time. So this tells me that the first term, a sub 1, is 6. And I know that the common difference is 4, because that's what I'm adding each time. Okay, so now for part B here, I'm seeing that it's dropping by 6, going down by 6, down by 6. So I know that my first term is 0. That's what a sub 1 denotes. And then my common difference is minus 6. That's what I'm subtracting each time. Okay, if we were not adding or subtracting the same number each time, it wouldn't be an arithmetic sequence. Okay, it might be geometric, and that's the next thing, or it could just be some other kind of sequence that we aren't going to be able to deal with today. Okay, this next one's dealing with fractions. What I'm noticing, I'm going from 1/3, and then if I add a third, isn't that 2/3? And if I add a third again, that's 3/3, which is 1. So to me, I know the first term, a sub 1, is 1/3, and I know the common difference is 1/3, or that's what I'm adding. Okay, so that's the first part of this. We were able to find the common difference. Now, once you know how to find the common difference in the first term, one thing that's useful in a limited sort of way is the recursive formula for an arithmetic sequence. So what you do is you write it in this format. You write a sub 1 for the first term, and that's what it is. It's just the first term in the sequence. And then to get the next term, that's what a sub n denotes, you take the last term, a sub n minus 1, and you add the common difference. So that's the next term. This means the last term we had. Okay, a form that's a little more useful for us is the explicit formula. Okay, so what this lets you do is this lets you find any term in the sequence. The recursive, in order to get the 20th term of that last sequence, I'd have to find the 19th term and then add the common difference. If I can write an explicit formula, then I can jump right to it. So this is the general form of it. What I want you to be able to think about, though, is really all this is a linear function. If I distribute that d through, do you see that really all we have is a y equals mx plus b? So a sub n equals the common difference, which is the same thing for as the slope, plus the first term minus the common difference, which is the y-intercept. And that's all we're dealing with. Now we can work with either form. Sometimes this is more useful. Sometimes this is more useful. For all the examples I'm going to do today, this is the more useful term. Sorry, not this one. Okay, but either works. Okay, so I'm using those examples we had in the first slide. So to find the recursive formula for this sequence, I know the first term is 6, and then to get the next term, I take the last term, and I'm going to add 4. See, and that is the recursive formula. So if I wanted to find, let's see, this is term 1, 2, 3, 4, 5. If I wanted to find the 6th term, a sub 6, I'd have to take the last term, which was 22, and add 4 to it. So that would make the next term 26. If I wanted to find a sub 7, well, I'd have to take my 26 and add 4 more to it, so that would be 30. Where it comes in the problem is, what if I wanted to find the 100th term? If I wanted to find a sub 100, say, well, I would have to do all of the numbers, a sub 8, 9, 10, right up to 99, and then substitute in the 100. So the explicit formula is what's the shortcut. So to write the explicit formula, in an unsimplified manner. I don't know if you remember that from the before. So I write a sub n equals the first term plus the common difference times n minus 1. So to get the nth term, I write a sub n. Now the first term in this sequence is 6. I know the common difference is 4, and that's n minus 1. So I could write it this way. I could also write it simplified by distributing that 4 through and then combining like terms. So a sub n equals, let's see, what is that, 4n plus 2, and that's in the slope-intercept form. Either formula works. I can use either one. Now suppose if I wanted to find the 100th, all I do is replace the 100th term, all I would do is replace n with the 100. If I'm going to do it with the unsimplified form, that'll be 4 times, well, let's see, 100 minus 1 is 99. And that would give me whatever that answer is. I could also substitute in 100 here, and I would get 400 plus 2 is 402. So as you see, either work. I didn't bother to do that one. I'm sure it's going to be the same. In fact, I know it's going to be the same. Okay, either way works. I honestly use this form more often than I do the simplified form, but as you can, for this problem, it certainly was easier to use the simplified form for it. Okay, let's do another example. Okay, so if we have to find the explicit formula, you could stop this and try this and then play this further to check yourself. So I am just going to jump in and do this. So for the recursive formula, a sub 1 is 0. A sub n equals a sub n minus 1 minus 6, because that was the common difference. So that's the recursive formula. The nth term formula, or the explicit formula, would be a sub n equals 0, which we really don't have to write, plus, I'm going to write negative 6, minus 6. Minus 6 times n minus 1. If we wanted to write that in simplified manner, we could write negative 6n plus 6. Either one of these is the nth term, it's the explicit formula. If I wanted to use this to predict, say, I don't know, how about the 11th term? I could do negative 6 times 11 minus 1 using this format here. Or I could do negative 6 times 11 plus 6. Either way, I'm going to end up with negative 60. Okay. So here's the last one with fractions. Recursive formula, you'd write the first term. And then to get the next term, we take the last term, a sub n minus 1, and we add 1/3 to it. It's just a matter of circumstance or chance that those are the same numbers. It isn't often the same number. Now if I want to do the recursive formula, I'm going to take my first term, explicit formula, the nth term formula. I'm going to take the first term plus the common difference times n minus 1. If I wanted to simplify that, I would have to distribute that 1/3 through. And then that would give me an interesting format. It would just give me 1/3 n. If you think about it, somebody who is a little more sharper than I am on this would notice, oh, first term, second term, third term, fourth term, fifth term. So that's another way to do it. Okay? So here's an example that the textbook authors thought was a good idea to write. So they want us to find the 11th term of the sequence. Well, let's see. I am just going to jump to the explicit formula here. So I know the first term is 2. Looks to me like it's going up by 4 each time. Is this the first problem? I believe it is. So the 11th term would be a 2 plus 4 times 11 minus 1. So 2 plus 4 times 10. So it would answer 42. That is the answer. Aren't they being funny? Watch Hitchhiker's Guide if you don't know what I mean. So, a little bit harder problem. They want us to find the first term and the common difference when they tell me the third term and the 9th term. Well, let's see. What do we know? Well, I know that the third term is negative 5, so a sub 3 is negative 5, so I can replace this stuff, right, which is negative 5 equals a sub 1 plus 2 times d, right? And then I know for the ninth term is 37. So that's the first term plus, well, let's see, 9 minus 1 is 8, so that's 8d. Well, if these numbers are coming from the same sequence, it must be those two a sub 1s are the same number. So I could do a system of linear equations. You could do this with matrices if you preferred. You could say 1, 2, a and d equals negative 5 and 37. Here, I can finish setting this up. And what do we got? 1 and 8. So you could type that into a calculator, do inverse matrices, and find your a and d. We can also do this, because this is just two systems, a system of two equations with two unknowns. Since this is just this kind of system, we could say that a has to equal a. I rewrote it, so that would tell me if I subtract 2d from both sides, I subtract 8d from both sides, I can use a substitution method, something from earlier algebra, right? I can say 5 minus 2d has to equal 37. Negative 5 minus 2d equals 37 minus 8d. And then I can just do a little bit of algebra here. What do I get? Add 8d to both sides. Add 5 to both sides. So that would tell me the common difference is 7. If the common difference is 7, a plus 14 has to equal negative 5. So subtract 14, a would have to equal negative 19. We could also do the same kind of check on the second one. I believe that's the same. So they want us to construct the sequence. So a sub n equals negative 19 plus 7 times n minus 1. If we simplify that, we'd have to distribute the 7 through. So 7n minus 7 and minus 19. So what is that going to be? A sub n equals negative 19. I'm sorry, not negative 19. Not letting me erase. Negative 19 is, what is that? Negative 26. So negative 26 plus 7n would be a simplified version of that formula. Okay, so for me, on paper, either one works. You might have to be flexible and be able to write it both ways. So, how do you find the sum of the first n terms? Another name for this is a series. This is an arithmetic series because it's arithmetic because I've got an arithmetic sequence, and I'm trying to add up all the terms in this arithmetic sequence, and they'll tell us how many to do. So the parts of this formula is, so this is the answer. If we're looking for the sum, you almost think series sum, S stands for sum. N's how many terms we have, and then we have the first term, and we have the last term. And those are the parts or the pieces we need in order to do this for an arithmetic sequence. So they want us to find the sum of the first 11 terms of the sequence. Well, one problem is I only know the first term, and I need the last term to do this. So I'll actually need to come up with the arithmetic the sequence, the nth term, to be able to do this. So I know the first term is 16. It looks to me like this sequence has a common difference of negative 4. Looks like it's dropping by 4. So that's my explicit formula. I need to find the 11th term in order to be able to find the sum of them. So 6 plus 4 times 11 minus 1 is 10. So let's see, what is that? 16 minus 40. If I'm doing my arithmetic right, that should be negative 24. Okay, so now to find the sum of them, let's see. I have 11 terms, so 11 over 2. My first term is 16. My 11th term is negative 24. So that would be 5.5 times, what is that, negative 8. So 5.5 is the same thing as 11 over 2. I guess I'm going to go back to a fraction, just because I don't have a calculator handy. I'm going to cross cancel. So the sum of those 11 terms would be negative 44. Okay? So this is another form that they'll often give us. This big Greek sigma means find the sum. And they told us how to generate. They didn't tell us the sequence. They told us how to generate it. They're telling us we're going to find the sum of the first 10 terms. So, I mean, to do this the long way, I could say, okay, if k is 1, the first term is going to be 10 times 1 plus 4, which is 14. So that's my first term. To get the next term, k is now 2. So I'm just using that formula to generate it. So that's going to be 20 plus 4 is 24. To get the next term, which is 3, k is 3, that's going to be 34. So to me, it looks like my common difference is 10. So I could go through the hassle of writing an explicit formula. I could write a sub n equals 14 plus 10 times n minus 1. Substitute in 10. I could find a sub 10, which is 14 plus 10 times 9, because 10 minus 1 is 9. So that's going to be 90 plus 14 is 104. Okay, so I could do that, and then I could use the formula, use that series here, sum of a series formula. The other thing I wanted to point out to you here before we do that is when I'm given this format or this definition for a sequence, I could just find the first term when k equals 1. That would be the 14. I can also just drop in 10 into this formula, which would be 10 times 100, or 10 times 10 plus 4, and get my 104 without having to construct this formula. Okay, so either way works. I can get it depends on what you want to do for work. Since I'm looking for the first 10 terms, sum of the first 10 terms, n is 10, and 14 plus 104, that's going to be 5 times, let's see, what is that, 118? So whatever 5 times 118 is, I'm going to cheat and use a calculator. I'm getting 590. Okay, so I hope that helps. So how about a word problem with these things? Well, let's see, they're telling me there's 8 rows. Tells me the first row has 5 musicians, the second row has 7, the third row has 9, and so on and so forth, up into 8. So I mean, I certainly could do this from a recursive viewpoint where it looks to me like the common difference is 2. So I could just keep adding 2 until I had the eighth row, the 8th number. I can also do this with an explicit formula, and that's what I'm going to choose to do. So to find the 8th row, I'm going to take the first row plus 2 times 8 minus 1 is 7. So 5 plus 14, looks like there's 19 musicians in the last row. Then if they want me to find the total number of musicians, I could certainly add up. I could find all 8 rows and find the sum of those numbers. I also can use the series formula. There's 8 rows, so 8 divided by 2. The first row has 5. The last row has 19. That's going to be 4 times 24, which is 96, if I'm doing my arithmetic right. Okay, and this is the same kind of thing you'll see. So hope this helps.